Is this greater than 1 or less than 1? Final answer? This series converges by which test?
RT.
By RT. What a cool test. What an awesome test. We'll do a couple more of these. And when the thing about the ratio test, when is it useful? This test, I mean, there are multiple problems we've done previously where you can use this. It's not so great when you get what limit? You do all this math and you go, I get a 1. You're going to have to go to another test. That's what I mean if you really, really dig this test. It is exceptionally well, though. I want to tell you where. When you got a mixture of exponentials and polynomials or monomials, because the integral test, geometric series, no way. Test for divergence, well, the limit was already 0. We can't do that. The limit of the sequence. Do you follow me? Whereas the limit comparison test, maybe, but this is just such a cool test. All right, let's try another one. Does it converge? It doesn't diverge. This is 11.6. Okay. This is number 8. I know the even answers are in the back and forth. N factorial 100 to the n. Now some of you might already know the answer, but I'm going to pretend like we didn't know it. You might already know this answer by another test, but I'm just going to go through the ratio test because I like the ratio test. Here I go. The limit as n approaches infinity of, what do I substitute for n? N plus 1. What do I substitute for n? N plus 1. And what do I divide? That's a sub n plus 1, right? And what goes in the denominator? The original. So it looks all scary right now, but we're going to clean this up. Hey, I got bars here, but do you recognize everything's already positive? So if you want, you can remove those bars right now. You can remove the bars right now because everything's already positive. Everything's positive. Let's do the flip. Flip it. Right? N plus 1 factorial. 100 to the n plus 1. Put a dot. Flip that over. 100 to the n over n factorial. And I was going to wait till everyone gets this written down. You're going to help me rewrite all this. Like, how do I want to write 100 to the n plus 1? Jessica, you were awesome. She goes 100 to the n times 100. I'll do that. Very good. Anybody know how to simplify this right here? We need to be able to do that. How do you simplify that? How do you simplify n plus 1 factorial over n factorial? So let's think about it. Way to go, Dave. It's just n plus 1, isn't it? Remember, this is n plus 1. What's 1 lower than n plus 1? And what's lower than n? 1 lower than n. N minus 1, what's this? N minus 1. Keep going. What's this equal to? N times n minus 1. What's going to cancel? Isn't this just n plus 1? By the way, some of you write this as n plus 1 times n factorial and let the n factorials cancel, right? But you see what we're saying? This is just n plus 1. That portion right there. If you got factorial over a factorial, you can always simplify it. So let me rewrite all this. What do I now have? Keep it nice and neat. I now have the limit as n approaches infinity of n plus 1 all over 100 because this cancels. Does anybody know that limit? What's the limit as n approaches infinity? N plus 1 over 100. That's heading towards infinity, right? So what's my answer? By the ratio test. This is way better than that alternating series test. We had to go to another test. It has a test for divergence. What happened is your limit is greater than 1 or not, or infinity. In this case, it's infinity. What can I say? This series diverges by the ratio test. The ratio test. Look the other way and I'll light your copy. I'll pick another one. I want to match some of the problems I put in your practice. I wish we went like 7 or 13. What do y'all think of this test? Isn't it cool? Awesome test. It's weird because we waited to the end. It's kind of like the cleanup. Like the cleanup hitter, it's the cleanup test. Hey, none of my other tests work. Geometric series test, integral test. We'll try the ratio test, right? Hey, I'm curious, did anybody have another test you could have used? It probably would have been less writing. Test for divergence. You are awesome. She said test for divergence. She recognized at the beginning factorial over an exponential, right? She knew this limit right here. She knew that limit does not exist. The limit of that sequence is going towards positive infinity, does not exist, and she could have just TFD. One sentence, she would have been done. But, you know what's great? Maybe a lot of you like the ratio test, and you want to use that to do the problem. There's nothing wrong with that, true? So some of these tests have multiple answers, others might just be like only one test. Hey, great. Hey, sometimes the ones that look so simple can be the ones that can be confusing. Did you notice I have a fraction over a fraction? And this is one like number 7, where it's so small in terms of the writing, there's not much. You might think, did I do it right? Oh, they use K. Every once in a while they use a K. I'll use K too. They use a fraction 2/3. I think I'll use 3/4. All right. There you go. This is my point. There's not much there. There's not much there. K times 3/4 to the K. Is this a geometric series? Be careful. Geometric series would have been just that. Right? Here's a geometric series. Maybe something like this. -1 to the n plus 1, 3/4 to the n. Sure? Everything is exponential. But you include this other n or another k, it's not geometric. Well, let's try the ratio test, because does anybody know how to integrate this? If you're trying, I'll do integral tests, right? And you've got a mixture of an exponential with a monomial. Does that make sense? Great test to use. Let's try it. What do we got to substitute? K plus 1, 3/4 to the K plus 1. Sometimes on a test, people get lost and it's all they write. What did I forget? Wait a minute, it's a ratio. It's the a sub n plus 1 over the a sub n. So that's all I did was the a sub n plus 1. Divided by, I'll put my bars. If everything's positive, you can remove those bars. Sometimes you get the -1 at the end. What do I get now? K. 3/4 of K. Okay. There we go. Now, how do you simplify that? That's 3/4 of the K times that? 3/4. I was about to race. I worry I raced that. Someone was still cocky, doesn't see. I'm just going to write it again. K, 3/4. K, 3/4 of K. What cancels? Does anybody, oh, I keep writing n. This is a variable K, right? I'll make that a K. I'll make this a K. Just because I had a K. You can use K. What's the limit as K approaches infinity of? Help me out here. Make sure I write everything down that's left over. I see there's a K plus 1 and a K. Anything else?
3/4.
Don't forget about that 3/4, right? See, if my eyes miss that, I think the limit's 1. And I'm going to say the test isn't conclusive. That 3/4 is there. I'll put it way out front. What's that limit? going to 1, 3/4 times 1 is what? 3/4. You can do L'Hopital's rule, or think of the horizontal asymptote on this thing. Is this greater than 1 or less than 1? Converges by what? RT. Yeah. Converges by ratio 10. Hey, we're going to do another one, but I want to put something down with this problem real quick. What if you had this? Whoop whoop. What's going to happen way at the end? Whoop whoop. Which would equal what? Whoop whoop. And that is now what? And what's the answer? Diverges. Someone see that? So, I mean, just a slight change in that, we see that. That's what we'll run through the whole test. All right, this problem, I'm going to find something that has like a -1 in there, -1 to the n. So it has a 2n plus 1. Okay. This one's busy. And when this is light number 13. There's a -1 to the n. It starts at n equal to 1. It's got a 10 to the n. It's got an n plus 1 and a 4 to the 2n plus 1. My goodness. Oh, we'll get it. Okay, does anybody know how to integrate this? All right. Is that a geometric series? No, no way. You got exponentials mixed with m plus 1s. Let's try the ratio test. All right, what's the limit as n approaches infinity of? That becomes -1 raised to the what? N plus 1? That's 10 to the? What's 10 to the n plus 1 become? 10 to the n times a 10. Can I start writing it like that now? Good. What's this become? N plus 1 plus 1 is? Now help me out here. 4 to the, you need to substitute n plus 1 right there. And you got to distribute that 2. So what would be 4 to the 2, substitute an n plus 1, and you got a plus 1. What is all that? What does that become? People just think you always add 1, you always add 1. Well, not in this case. If I substitute an n plus 1 for that n, I got to distribute the 2. 2 times n plus 1 is 2n plus 2, plus a 1 is? Say again?
Right here, 4 is 2n plus 1, so it will not be 2 times 1 plus 1. You back up.
You're asking about here?
No, that's not. 4.
The original problem?
Yeah.
You wanted to do what?
You backed up the 2, like you did over there.
You're factoring?
Did you not back up the 2 again? Plug it in. Okay. Oh, yeah.
This is the original problem.
Okay.
And what we do is we substitute n plus 1 for n.
Okay.
We substitute n plus 1 for that. All right. Now, what do I have to divide it by? That's a sub n plus 1, isn't it? Yeah. You got to divide by a sub n. What's a sub n? Just everything I have. Now here, right here, I'm going to write down the original expression. You got 10 to the n. What else you got? n plus 1. And you have 4 to the 2n plus 1. Now, in one of these absolute value bars going to do that -1 to the n plus 1? It's going to make those negatives go away. Does that make sense? What's -1 to any power? You know, it's either a negative or a positive. The absolute value bar is just going to make that positive. And we're going to flip this upside down and cancel stuff out. True? All right. Let's see what we got. Goes that approach infinity, you got -1 to the n. Can I write this as -1 to the n times -1? Then you got a 10 to the n times a 10. All over n plus 2. This would be 4 to the 2n times 4 to the third, right? Does everyone look how I wrote that? Awesome. Dot, now what goes upstairs, and I'll flip this other thing. I've got an n plus 1 upstairs, I've got a 4 to the 2n. That would be 4 to the 2n times a 4. And this is all over. A -1 to the n, and a 10 to the n. And I'll put these bars. We got our bars right there. What cancels? Boy, a lot cancels. Can we start with a 4 to the 2 n's? Oh, kind of question.
Yeah. If we take off the bars, can we just write it as 1 instead of -1?
You sure can.
Okay.
You can do it right away. Because that's all it's there for. You're like, oh, it's just going to make those -1s go away. You can ignore this from here on out. So he's saying, when he's like, this is going to cancel this, but he knows the x value -1 is just a 1. He's going to go right to that. And Connor's doing 2 steps at once. It's a good idea. What else cancels? 4 to 2 n's go away. 10 to the n's go out. What do we have remaining? Remember, the absolute value of -1 is a what? A 1. So what's remaining? Come on, we got this. This problem looked intimidating. We got this. You got a 10 left over, what else? The 4, what's 10 times 4?
40.
You got a 10, you got to multiply a 4, what's left in the denominator? 4 cubed? Anything else left? What is 4 cubed? 64. Anything else left over? Keep looking. Ah, the n plus 2 is still there, right? Okay. Let me write that again. What is that? 40 over 64 times n plus 2. Oh, that was n plus 1? Oh, the n plus 1's up there too. Very good. What's that limit?
5/8.
40 over 64. Reduced to 5/8. Is this greater than 1 or less than 1? Less than 1. 40 over 64 is less than 1. This converges by what? RT. John? Any of the weird ones with the factorial? Okay, last one, number 3. But I'm not going to raise till everyone has this. Hey, Connor's suggestion, Connor likes this. Others may do this. Remember how we can keep putting these bars down? That -1 to the nth is just going to make it a positive 1. He goes, he can eliminate that right away. If it's, it saves writing. Some of you might do 2 steps at once when you see that's 4 to the 2n times 4 cubed. And Nicholas, you were fine with that substitution. That's the only weird thing. It's going to happen again on this problem. Because that's why I wanted to make sure. If I didn't show one of these examples, Nicholas, what happens with students, they think in the ratio test you just always add 1. Where we really substitute up m plus 1 for each n. All right, where's the last one? This is an even problem. This is number 6 from the text. And this is what they have. Does this series converge or does this diverge? N equals 0, go to infinity. Ah, it's starting at 0. -3 n, 2n plus 1 factorial. All right, let's go through the list here. Can I use geometric series test? No, that's out. Right, everyone? Geometric series test? That's out. How about test for divergence? How about the test for divergence? I do it? Nope. Limit's equal to 0 of the sequence, everyone agree? How about integral test? Can I use integral test? Integrate with the factorial? No, that's not working. Well, what's a great test to use? It's got a mixture of factorials and exponential. Let's try the awesome ratio test. Okay, so we do the limit. Then it approaches infinity. -3 to the n plus 1. All over. I need some help. Okay, Nicholas will help me with this. Oh, wait, I'll wait till you're done running. I gotta substitute an n plus 1 in there. 2 times, right, he goes 2 times parentheses n plus 1 plus a 1. That's what that means, with the factorial. Someone see that? This is what this means. I'm thinking of all this, and it's a factorial. Well, what is all that? It means I gotta substitute n plus 1 for that n, and then distribute the 2. 2n plus a 2 plus a 1 becomes 2n plus 3. Okay with that? Yeah? So I'm going to rewrite this as 2n plus 3 with the factorial. Unless someone wanted to write it like that in their notes. Did anybody want to write it like that in their notes? No? Okay, I'm going to write that as 2n plus 3 factorial. All right, that's 2n plus 3 factorial. Excellent. All right, we're rocking and rolling. Everyone put the fraction bar. Now what? Oh, the original. Factorial. Hey, put the bars. Put my equal sign. Limit as n goes to infinity. That's -3 to the n times the -3. All over 2n plus 3 factorial. Absolute value bars. I'm going to flip the bottom. 2n plus 1 factorial. -3 to the n. So what cancels? The -3 to the n's go out. What's the absolute value of -3? 3. Here's the part you need to help me out with. How do I simplify that? How do I simplify 2n plus 1 factorial all over 2n plus 3 parentheses factorial? Well, do you notice something? This denominator is 2n plus 3. What's one less than that? 2n plus 2. What's one less than that? 2n plus 1, etc. And what will cancel? Everything afterwards will cancel out except for the 1 over 2n plus 3, 2n plus 2. So let me write this again. This is what we have now. I'm taking off the bars, and we're going to have this answer. We have a positive 3, because the absolute value of -3 is 3. All over, let me write this, 2n plus 3 and 2n plus 2. n plus 3, 2n plus 2. And what do you get there? What's that limit? 0. Can I use a ratio test when you get a limit of 0? Yes, you can. That's throwing people off sometimes. They go, they got to equal 0, and they go, I guess I can't use a ratio test. Of course you can. That limit is less than what? 0 is less than 1. Right? This series converges. Converges by the ratio test. I'll just put RT. Woohoo! Super job, everyone. And we covered everything, even the weird 2n plus 1s and 2n plus 3. And thanks for bearing with the heat. Boy, it's hot. My chalk's breaking all over the place. Super job, everyone. Hey, keep in mind, section 11.7 is just a summary section where they just throw a bunch of problems at you. I picked some to practice. And you go in there and you're like, which test am I going to use? You can check the back to see if you get it right. Keep in mind, sometimes there's more than one test, right?